Have you ever really stopped to think about how the most complex thing in the entire universe, your brain, actually runs itself?
I mean, it's just a wild puzzle when you think about it. Your brain isn't some static computer. Nope, it's this living, breathing system with countless little parts, all chattering away, creating everything you think, feel, and do. So how on earth does it all hang together?
To really get a feel for the scale here, just look at that number, 86 billion neurons. That is an insane number. It's more than the number of stars in our galaxy. Trying to coordinate all of those little pieces is a massive, massive control problem. So where do we even start to look for an answer?
Well, the first big clue, believe it or not, comes from physics. It turns out the brain has to maintain this incredibly delicate balance, this perfect sweet spot between complete order and total chaos. And that state has a name. It's called criticality.
Okay, so imagine you're trying to light a campfire, but all your wood is damp. You get a little spark, it flickers for a second, and then it just fizzles out. That's kind of like a subcritical brain. A thought starts, but the activity just dies. Information doesn't go anywhere. The whole system is just too quiet, too stable.
Now, on the flip side, you've got the supercritical state. Think of a wildfire ripping through a forest or a nuclear chain reaction. One tiny spark just explodes and overwhelms the entire network. In the brain, this is basically a seizure, just totally uncontrolled, chaotic activity that's not useful for anything.
The magic happens right on the razor's edge between those two extremes. That's criticality. Here, a little spark of activity can travel and spread, but without exploding. It can sustain itself, letting these beautiful, complex patterns form so we can actually process information. It makes the brain incredibly flexible and responsive.
You know, by hanging out near this critical point, the brain gets this amazing ability to handle information across huge scales of space and time. It's perfectly balanced to react, to learn, and to adapt to whatever the world throws at it. So this brings us to the next massive question. If the brain needs to stay perfectly tuned to this critical point, well, then something must be doing the tuning, right? There has to be some kind of biological control knob. So what is it?
All right, if we were going to write up a job description for this master controller, what would it look like? Well, first, it's got to have global reach. It needs to influence pretty much the whole system. Second, the controller itself has to be simple, so a small signal can have a huge effect. And third, it has to work like a volume knob, basically turning up or down how easily individual neurons get excited and fire.
So, what system inside our heads could possibly fit a description like that? What tiny little system has that much power and can tune the entire brain? And here's the really wild part. The answer isn't where you might think. It's not in the super-evolved, smart parts of our cortex. No, it's buried deep down in the ancient, almost primitive parts of the brainstem and forebrain. We are talking about the ascending arousal system, or AAS for short. You can think of it as the brain's master switch for wakefulness and attention, and it is perfectly placed to be our master controller. This system is just a perfect match for our job description. The AAS has surprisingly few neurons of its own, but it sends these long, branching connections out to practically everywhere else. And by using special chemical messengers, it can directly change the gain, or the excitability, of other neurons, basically tuning the whole brain either towards or away from that critical sweet spot.
But the AAS isn't just some simple on-off switch. It's way more sophisticated than that. It's more like a toolkit. And it uses all these different chemicals, we call them neuromodulators, to fine-tune the brain for all sorts of different jobs.
These chemicals can completely shift the brain's operating mode. Think about it like changing the shape of a landscape. One chemical might dig the valleys deeper, locking you into a really focused, efficient way of thinking. But another chemical might flatten that whole landscape out, making it way easier to wander around and find new creative solutions when you're feeling stuck. So let's peek inside this toolkit. You've got acetylcholine, which acts like a spotlight, sharpening your focus. Then there's noradrenaline. That's your internal alarm bell, right? It signals surprise and makes you super vigilant. Serotonin helps balance your mood and encourages patience. And then there's the famous one, dopamine. That's the powerful reward signal that drives your motivation and tells your brain, hey, that was good, do it again. Let's walk through a simple decision. Dopamine starts by boosting the brain activity for a few competing options. As soon as a winner starts to emerge, it triggers this whole cascade through other deep brain structures that act like a gatekeeper. They basically release the brakes, which sends a big go signal to the cortex to make the action happen. This shows dopamine isn't just about feeling good, it's actively helping build the decision itself.
Okay, so we've got this beautiful, elegant control system that's constantly tuning our brain's dynamics. But so what? Why does any of this actually matter? Well, the implications are just huge, and they connect this deep, nitty-gritty neuroscience to our actual everyday lives.
Understanding this master controller helps us get to the bottom of how we focus, how we make choices, and maybe, just maybe, how consciousness itself comes from this coordinated dance of 86 billion neurons. It also gives us a whole new way to think about what's going wrong in everything from dementia to depression, and why states like being asleep or under anesthesia are so fundamentally different from being awake.
And this all points to a really cool idea about what might make us humans so unique. The author of the paper we're looking at, James Shine, he suggests that maybe during our evolution, the connections from our advanced cortex back down to this ancient arousal system got way stronger. This could have given us much finer control over our own brain states, which would let us navigate a much more complicated world.
So let's end with this final thought, and it's a big one. If our entire perception of reality is being actively shaped and fine-tuned moment by moment by these ancient chemical controllers, then what does that really mean for our idea of a stable, consistent self? It kind of suggests that who we are isn't a fixed thing at all, but this constant, dynamic process of self-creation, all managed by the brain's own incredible master controller.